Hello engineers, welcome to the new video of the course, and in this particular video we are going to understand the concept of AC and DC source. So DC is nothing but direct current, AC is nothing but alternating current, right? So if you could remember when we saw the session of voltage, okay, when we understood that what exactly a voltage is, so at that particular time I just drew this particular symbol for voltage. Okay, so this is the DC voltage source, okay, or DC voltage. Okay, and this is how AC voltage looks like, I mean symbolically. So this is the symbolic representation of AC source or AC voltage source, to be precise. Okay, now we'll try to understand its definition or kind of explanation, and then we'll try to deduce each and everything one by one. So in DC current, or basically in DC source, voltage is constant, or voltage remains constant, and therefore current moves only in one direction. In case of AC, voltage keeps on changing, therefore current moves in back and forth direction. In other words, we can say that the direction of current keeps on changing. Okay, so we'll first go with the DC source. Okay, so you see over here I have just taken one basic circuit wherein I'm just applying certain voltage to this particular resistor, and due to which a current I is generated which flows in this particular direction, right? Okay, now let's say if I keep this particular circuit same for, let's say, 1 hour, 2 hour, 3 hour, maybe 1 minute, 2 minute, 3 minute, and so on, right? So what will I see? Across this particular resistor, you see the voltage keeps the voltage is constant, right? Even though I'm increasing time, let's say at 1 minute, okay, if at 1 minute if I see the voltage, let's say voltage is V. Let's say if I come at around 37 minutes, right, again the voltage will remain same, that is V. Okay, let's say if I come maybe if I keep this particular circuit same, I'm not changing anything in the circuit, and let's say if I come maybe after 2 days, so after 2 days as well the voltage across this particular resistor will be V. Okay, so what does that means? That means the voltage is constant throughout, right? The voltage is constant. Okay, and since the voltage is constant, therefore the current I is generated and it will move in this particular direction. And if you could remember, I already mentioned that what my current let me change the color. Yeah, the current I, it moves from positive voltage to, right, if you could remember that, moves from positive voltage to negative voltage, right? Negative voltage, this is what I clearly mentioned. And you see, since there isn't any change in a voltage, right, not in nor in magnitude, and also not in the into the terminals, right? So therefore the voltage will remain constant throughout, and since my voltage is constant, therefore current will also be constant. Okay, so I'll just write over here, since voltage is constant, okay, which you can clearly see over here, therefore current I is also constant. Okay, therefore that means what, the magnitude of voltage and current, they are not changing with respect to time. Okay, great. Let's proceed further. Let's take another example wherein I'm applying a kind of square wave like of signal. Now if you are unable to understand that what exactly is square wave, that's absolutely fine. Let me just write over here as R and R over here. Okay, so what does that mean? Let's say for certain time interval I'm applying voltage as shown over here. Okay, after certain time interval I'm just changing the terminal of the voltages. Okay, so you see the positive terminal of the voltage is above over here. Okay, after certain time interval I'm just changing the terminal of the voltage. So you see over here the positive terminal of the of that particular battery or that particular source, it is downwards, right? Okay, I hope you are able to understand this. So what kind of voltage are you expecting? Okay, what kind of voltage are you expecting? Just pause this video and try to think in your mind that what kind of voltage are you expecting. Let's say at around 0 seconds, okay, I started this particular circuit. So for 1 second, let's say for 1 second I'm getting certain positive voltage. I'll just write over here. So for 1 second I'm getting certain positive voltage, let's say plus V. Okay, after certain second, let's say at around 2 seconds I'm getting certain negative voltage, let's say minus V, and keeps on, and I keep on doing something like this. So what voltage will I get? what voltage are you expecting to get from this kind of circuit? Alright, I believe that you have tried your best to think upon this particular logic. Now it's my turn, so you will get, kind of this, something kind of this kind of logic. Okay, so you see over here at 0th second I started the circuit at around 1 second. So at 1 second, okay, till 1 second we are getting certain positive voltage. After 1 second, okay, we are getting certain negative voltage up till 2 seconds, right? From 2 to 3 seconds we are getting certain positive voltage, okay, and from 3 to 4 seconds again we are getting certain negative voltage. Okay, so this kind of signal is known as AC signal. Okay, this kind of signal is known as AC signal, and as you can see, with respect to time, as my time is increasing, you see, as my time is increasing from 1 to 4 second, the voltage keeps on fluctuating, right? The voltage, from 0 to 1 second it is plus V, from 1 to 2 second it is minus V, again from 2 to 3 second it is plus V, from 3 to 4 second it is minus V. So you see the voltage is fluctuating, right? So I'll just write over here, the voltage keeps on fluctuating, voltage fluctuates, okay, and as my voltage is fluctuating, what exactly is happening? You see, for this particular interval, that is from 0 to 1 second, right? From 0 to 1 second, what do you think? In which direction the current will move? I know you will say that the current will move from positive voltage to negative voltage. So in this particular circuit, the current will move in this particular direction. Yeah, that is absolutely right. Then what about this particular circuit? Again, the logic is same. In which direction the current will move? The current will move in this particular direction, from positive to negative voltage. But if you see over here, okay, over here the current was moving in this particular direction, and in this particular circuit the current is moving in the opposite direction. Okay, the magnitude will remain same because you see the voltage is fluctuating from plus V to minus V. Let's say voltage is plus 5 volts to minus 5 volts, right? The voltage is fluctuating in between these two magnitude or these 2 points. So the direction of current will change, but the magnitude will be same, right? So let's say if the magnitude is 2 ampere, okay, over here. So over here as well you will get magnitude 2 ampere. Just the thing is that you will get minus 2 because it is moving in the opposite direction with respect to this one, right? That's the only thing. Okay, I hope you are able to understand this. Okay, so this is how the current moves. Okay, so what we observed over here, as my voltage is fluctuating, therefore current also fluctuates. Okay, therefore current was also fluctuating in this case. Okay, so this particular scenario, this entire scenario is known as alternating current, okay, or AC source. Why? Because we had applied certain AC voltage over here. I hope you are able to understand this. And due to this, the current is moving back and forth. So you see current is moving in this direction. After some interval, it is moving in another direction. So back and forth direction. So that's why I wrote this particular word in this entire statement. So this is the basic idea of the AC source. Okay, now there is one question in my mind, like if I want maybe this kind of signal, so according to you, what changes I need to do in this particular circuit? Okay, in this particular entire scenario, what changes do I need to do to get this kind of waveform? Okay, so you see over here we are getting kind of a square like signal. What I want is that I want some sinusoidal signal. So according to you, what changes you need to do in the circuit so you can expect this kind of signal? Okay, so it's my request to you all guys that you please pause this video over here and try to think in your mind. Okay, like what modifications are needed to achieve this particular waveform. Okay, please pause the video and try to think. Alright, I believe that you all guys have tried your best. Now it's my turn. So if I look at this particular circuit very clearly, for that let me just zoom out this entire circuit. Sorry, not circuit, this particular waveform, my bad. If I look at this particular waveform very clearly, so let me just zoom out this particular waveform and let's try to deduce certain things over here. First of all, what we know is that this is the AC waveform. Okay, so we are dealing with the AC circuit, right? That's fine. The next thing that we need to observe, as I already mentioned, that first of all, like whenever you get any sort of thing, you just need to observe. Okay, so at the 0th second, the voltage is 0. Okay, so this is time and this is my voltage, right? So at 0th second, we have voltage as 0 volt. Okay, let's assume that this is my 1 second. Let's assume that this is my 1 second. So at 1 second, let's assume the voltage is 1 volt. Great. Let's say at around 2 seconds, okay, so at around 2 seconds the voltage is 2 volt. Similarly, at around 3 seconds the voltage is 3 volt, something like this. I'm just drawing it roughly so that it will be clearly visible to you all guys. Let me erase each and everything first, and let me erase this seconds as well. So yeah, at 2 volts we have 2 seconds, and at around 3 seconds we have voltage as 3 volts. So this is 3 seconds, we have 3 volts. Maybe at around 4 seconds we have voltage as 4 volt, and at around maybe 5 seconds we have voltage as around 5 volts. Okay, something like that. Okay, I just drawn it little roughly so that it will be clearly visible to you. Okay, I hope this particular part is crystal clear. Now let me come over here and let me just draw that once again over here so that it will be clearly visible to you what I want to convey, like what modifications what modifications are needed in this particular circuit. So let's say at around t is equals to 0 second, right, we have voltage as what? Voltage as 0 volts, right? So what will be the current? Since my voltage is 0, so the current will be, let's say, 0 ampere. 0 ampere. Okay. Then let's say if my time increases to 1 second, let's say at 1 second what we saw? At 1 second we have voltage as, let's say, 1 volt, and let's say current we will assume current as 1 ampere. Great. Okay, that's great. Let's say if I am moving forward, let's say at t is equals to 2 second, the voltage is how much? Again we'll assume it as 2 volts, and current is how much? Let's say 2 ampere. Okay, not necessary that you will get this set of voltages and this set of current. I'm just taking this random magnitude because it will be pretty easier for us to understand this particular concept. Okay, at t is equals to 3 sec, voltage will be, let's say, 3 volts, current will be, let's say, 3 ampere. Let me bring this entire thing little down. Okay, and then let's say at t is equals to 4 second, we have voltage as 4 volts and I as 5 ampere. Similarly, sorry, my bad, 4 ampere. Similarly, at t is equals to 5 second, we have voltage as 5 volts and current as 5 ampere. Okay, so what can you observe based upon this entire scenario? So what we can observe is, as my time is increasing, okay, as my time is increasing, I am increasing my voltage slowly, right? I'm increasing my voltage slowly. Okay, let me change the color. As my time is increasing, you see, I'm increasing my magnitude of voltage slowly, right? In the previous scenario, what we were doing, you see, as my time increased, I just change the voltage to certain magnitude directly, right? Let's say from I was present at around 5 volts, at around 1 second, quickly I changed the voltage to minus 5 volts, right? Okay, so we were just changing the terminal of the battery. If I take it as a battery, right, I was just changing the or shifting the terminal of battery, plus minus, right? But over here what I'm doing, you see, over here what I'm doing, I'm just increasing the magnitude of the battery. Okay, if I take it as a DC source, I'm just increasing the magnitude of battery, or basically voltage source. I'm just increasing the magnitude of the voltage source. Okay, as my time is increasing, I'm just increasing the magnitude. Okay, after that what I'm doing, I waited at certain point, let's say at around 5 seconds I waited, as I got the voltage as 5 volts and current as 5 amperes. After that I just reverse this particular process, right? I start to decrease the voltage. Okay, and just remember, your time cannot decrease, right? Your time will always be increasing. You cannot decrease the time. Let's say you decrease the time and then you say, let's say at what will happen at around t is equals to minus 1 second. It's unrealistic, right? There isn't any such concept, right? Minus 1 second. Okay, so the time will keep on increasing. Okay, from 5 it will go to 6, but you are decreasing the voltage, and since you are decreasing the voltage, so you are decreasing the current as well. Okay, So let's try to understand how we can achieve this kind of signal. Okay, so you see at t is equals to 0 to 5 second, the voltage will increase, right? So this is the voltage. So you see the voltage is increasing. Let me change the color. Yeah, so you see the voltage, it keeps on increasing up till this particular point. Okay, after that what is going to happen? Till this particular point the voltage is increasing. Yeah, after that what is going to happen? As clearly mentioned, we are going to decrease the magnitude of the voltage. Okay, we were present at 5 volts. After that we are going to decrease it from 5 to 4 to 3 to 2 to 1 and eventually to 0, right? So you see from 5 volts we are decreasing it to 4 volts. Okay, so I'll just continue over here. 4 volts, okay, and then 3 volts, something like that, 2 volts and 1 volt, and eventually we have 0 volts. And you see the time is increasing, right? You cannot say that the time is decreasing, right? So let's say if it was at around 0 second, over here we have 5 second, my bad, it's not volts, it is 5 second. So to move from 5 volts to 0 volts, we need another 5 seconds, so that counts as 10 seconds. So at 10 second we have 0 volt. Okay, at 10 second we have 0 volts. But the most important thing is that, just by increasing the magnitude of voltage slightly, after certain second we are able to achieve this kind of signal. So this is how we are able to achieve the AC waveform, this particular sinusoidal AC waveform. I hope you are able to understand this, because in future we will be dealing with this kind of signal. So this is my analog signal. Why? Because you see it has infinite number of values, right? If you go from 0 to 1 volts, there are infinite values, right? 1.1, sorry, not 1.1, my bad, 0.1, 0.1111, 0.1222, something like that, right? There are infinite values between 0 and 1. Similarly, there are infinite values between 1 and 2, right? 1.0001, 1.0002, 1.111, 1.122, infinite values, right? So basically this kind of waveform, it covers all of the values. I hope you are able to understand this, right? So that's why it is known as analog signal. This is very, very important. Analog signal. This is my analog signal, because it has variety of values in it, right? Over here you see in this scenario we had just two values, plus 5 volts, minus 5 volts, that's it. Okay, so generally we refer this kind of signal as digital signal. We don't need to go in that detail what is analog and digital. That's not the point of our interest. This is just for your information. Right now we are dealing with AC and DC sources, right? And this is how we are able to achieve this particular signal, right? Now take this as your homework. What will happen? I mean, how exactly you will achieve this particular negative half, right? So this is known as positive half of the signal. This particular part, it is known as positive half of the signal, and this particular signal, it is known as negative half of the signal. Negative half. So treat it as your homework. How exactly you will achieve, let's say from 10 seconds to 20 seconds, how you will be able to achieve this particular signal. It's pretty simple. Your time is going to increase. That's the only thing. Okay, and the values you feed over here, you just need to put it as negative. Okay, all of them as negative. Okay, from 0 you are moving to minus 1, minus 2, minus 3, minus 4 and 5, and eventually you will again come back from minus 5 volts to 0 volts, right? I'll just show it to you. Okay, you just take it as your homework. So this was 0, this was minus 1 probably, minus 2, minus 3, minus 4, minus 5, and eventually from minus 5 you are going to again back to 0, minus 4, 3, 2, 1 and eventually 0. So this is how things work. So treat it as your homework. Okay, see why I'm taking time to explain each of this particular point, because I want that you should be comfortable over here. Okay, now let's proceed further. I hope you understood this particular part. Okay, so now the question over here is that how exactly the current will move, as clearly mentioned. So from here to here, you see, let's say at around 1 volt. Okay, let's say at around 1 volt I have current as 1 ampere. So the current will move little slowly, 1 ampere, right? At around 2 volts the current will be 2 ampere, so it will move little quickly. 3 volts the current will be 3 ampere, so it will again move little quickly as compared to the previous one. At 4 ampere the current will move little quickly, and at 5 ampere again the current will be maximum, let's say 5 ampere. Okay, it will move very quickly. This will be the fastest speed that the current will achieve or the electron will achieve, right? 5 ampere, right? But what will happen after this particular point? Let's say this is 5 volts. Okay, after this point again I'll get 4 volts, right? Hope this particular part is clear. So this will be 4 volts. So for that, what will happen? At around 4 volts at this particular point, the speed of the current decreases. Okay, similarly at around 3 volts, again the speed of the magnitude of the current decreases. Okay, at around 2 volts again, you see this is the decreasing graph, right? The graph is decreasing. So that means what? That means the voltage is decreasing, and as my voltage is decreasing, so the current also decreases, and this is what I mentioned, right? Okay, the direction of current remains the same. Okay, why? Because we have positive voltage over here and negative voltage over here. Getting the point? Okay, see, positive voltage over here and negative voltage over here. The direction will remain same. Just the thing is that in this phase your magnitude was increasing, right? In this phase magnitude was increasing, the magnitude of the current, and in this phase the magnitude of the current, it is decreasing. Okay, and at around 1 volts you have current, you have the magnitude of current as 1 ampere, and at around 0 volts you have current as 0. Okay, this is what it means. I hope you are able to understand this. Okay, now that I have explained you this particular part, treat this particular part as your homework. For negative half cycle, okay, for negative half cycle, what will be the direction of current? I'll just give you an idea. So you see, for negative half cycle, the positive sign is over here, right, and negative sign is above. So the direction of current will be this. Okay, so just try to think that how the current will behave. Obviously the current is going to increase in this particular direction, and then it is going to decrease, right? Just try to take pen and paper, try to draw it with your rough hand, and just try to think, right? Okay, why I'm giving you all of this thing to do? Because I want that you should be quite comfortable in AC and DC circuits, right? Because we are going to see AC and DC circuits as we move further and further, and I really don't want you all guys to be, you know, confused at that particular point. So that's why I'm taking a lot of time. I'm explaining each and every point step by step. Okay, great. Now, yeah, so basically we get AC signal from this particular switches. I mean this particular power supply. One sec. Yeah, from here. Okay, I hope you had seen the switchboards in your home. Okay, we connect maybe, you know, the wires, or maybe wire of your laptop, okay, of your computer, right, whatever that is. So over here we get the AC signal. So I'll just write over here, from this particular terminal we get what? We get certain AC signal, right? We get certain AC signal, something like this. Okay, I hope this particular part is clear. And the voltage is very, very high. It is not 5 volts, 10 volts, it is 240 volts. 240 volts peak to peak. It is 240 volts. Okay, the supply voltage is 240 volts. That means the AC voltage that comes from this particular terminal, okay, or this particular channel, it is 240 volts peak to peak or 120 volts peak. I'll explain you, don't worry, what exactly is peak to peak and peak. Whereas if you see the coin cell, or maybe the batteries, they provide what? They provide DC voltage or DC source. Okay, they provide DC voltage. That means they are responsible to provide a constant voltage, as we saw over here. Okay, on contrary, if I want to give you example of AC source, it will be mic. So right now I'm speaking in front of you, right? I like whatever the word that I'm uttering. So basically my mic receives some AC signal. So this is how the AC signal looks like, and this is my mic. Let's say this is my mic. So mic is actually getting this particular input. So this is what my voice is, nothing but my AC signal, right? I hope this particular part is clear, right? Okay, but the magnitude of this particular signal, it is very, very less. It is in millivolts. Okay, so as of now you don't worry about that. Okay, it's fine even if you don't understood this particular part. It's not required as of now. We'll see that in the analog electronics when we will deal with BJTs and op amps. So over there we generally, or very frequently, we play with the millivolts or microvolt signal. So that is the part of the discussion which we'll discuss in some other course. That's fine. Okay, now there is one more term that is involved when we deal with certain AC signal, and that is the frequency. Okay, so what is the frequency? Frequency is nothing but the number of waveforms that occurs in 1 second. Okay, so let me just write over here the definition of frequency and the definition is number of waveforms that occurs in 1 second. In 1 second. So if I say this as, let's say, 1 second, okay, 1 second, this as 0.5 second, and this as 0 seconds, right? So what is the frequency? So the frequency is nothing but 1 hertz. Okay, the unit of frequency is hertz. Let me just write over here, unit of frequency is hertz, Hz. Okay, the frequency is 1 hertz. Why? Because you see, at 1 second we are just getting one waveform. Okay, one entire waveform I'm talking, not this particular positive half or negative half. I'm talking about both positive and negative half. Okay, so we are at 1 second we are getting what? We are getting the only one waveform. Okay, sorry. Okay, now let's say, I'll just erase this particular point. Sorry, let's say, let me erase this as well. Yeah, let's say if I consider this as, let's say, 1 second, if I consider this as 1 second, let's say this as 0 second. Okay, let's say this is a 0.25, this as 0.5 second. So what will be the 0.5 second? Yeah, what will be the frequency now? Well, the frequency will be what? Just pause this video and try to think. The frequency will be 2 hertz. Okay, right now for this particular waveform the frequency will be 2 hertz. Why? Because you see, in 1 second we are getting two such waveforms. See, one, this is my first waveform, and then this is my second waveform. So we are getting two waveforms in 1 second, so that becomes my frequency, that is 2 hertz. I hope this particular part is crystal clear. Okay, so this is not the exact definition. Maybe you can just Google the exact definition, you will get that on Google. Okay, I'm just giving you this definition so that your concept should be clear, right? Okay, you just, because whenever you learn anything, you just remember the entire concept, you don't remember the definitions and all. It's not that important according to me. Okay, so the electricity which comes in your home, okay, that means the electricity through which you charge your laptops or maybe your cell phones and all, that means this particular terminal I'm talking about, right? 3 pin. So let me just write over here, the electricity is very, very important point. The electricity which we receive in our homes has voltage peak to has AC voltage of around 240 volts. Okay, peak to peak, and frequency of around 60 hertz. Okay, some country has this frequency of around 50 hertz as well, 50 hertz. So basically most of the European countries has frequency of 60 hertz, maybe European and American countries as well, whereas most of the Asian countries has this frequency, that is 50 hertz, Asian countries. Okay, now so what does that mean? Like, what exactly is 50 hertz? That means what? 50 such AC waveforms are repeating in 1 second. Okay, so just to give you an example, the formula for frequency, let me just write the formula as well. The formula for frequency is 1 by time period. 1 by time period. So this is the formula for frequency. You just need to remember it. It is very, very important formula. It is very easy as well. Okay, so what does that means? Let me just write over here. First of all, I'll just need to clear this point. 240 volts peak to peak. So what does that means? That means you see over here, the positive half is of 120 volts. Okay, and the negative half is of minus 120 volts, right? So when I want to add them, so that subtract them, so overall voltage, if I want to calculate the overall voltage AC, it is nothing but peak to peak voltage, right? Peak to peak means what? From this peak to this peak. If I want to calculate this peak to peak voltage, so that will be 120 minus of minus 120, right? So that becomes what? 240 volts peak to peak. That becomes my peak to peak voltage, right? I hope this particular part is clear. So that is my peak to peak voltage. Whereas if I am talking about peak voltage, so that will be 120 volts. Okay, 120 volts PP. I hope this particular part is crystal clear. Okay, now let's come to this particular part, the frequency. Yeah, so I clearly mentioned that the electricity which comes in our home, it has frequency of, depending upon the countries. Some countries have 60 hertz, some have 50 hertz. So let's say if I'm taking 60 hertz, so time is equivalent to 1 by f. You just need to do the reciprocal, or else you just need to shift these two parameters, right? So it's one and the same. So if I'm taking 60 hertz, so that will be how much? 0.016 seconds. 0.016 seconds. That means what? In this second, that means in 0.01 seconds, we are getting this one complete cycle, right? Okay, and if you multiply it with 60, you will get roughly as 1 second. So in 1 second, we are getting 60 such cycles. Okay, in 1 second we are getting 60 such cycle in 1 second. I hope this particular part is crystal clear, because I know most of the guys, they somehow they don't know what exactly is the frequency in case of current electricity. Okay, maybe they know the definition, but they don't know the exact idea that what exactly is the frequency is. Okay, so just remember this particular point. Whenever someone says that the electricity which comes in your home, it has frequency of around 60 hertz. So that, what does that mean? That means this entire cycle, that means from 0 to 120 volts, from 120 to minus 120, and from minus 120 to 0 volts, this entire cycle, it gets completed within 0.01 second. Okay, so this is how quick it is. Okay, you just blink your eye and maybe 10 to 20 such waveforms are completed. Okay, in fact, I believe that blinking of eye takes somewhere around 0.5 seconds, so maybe 30 such cycles may get completed. I'm not so sure about that. Okay, so this is how quick it is. Okay, so I'll just write over here just for your information. This one cycle is, this one complete cycle, it gets completed in how much? 0.016 second. Okay, great. So just remember this particular point. I had intentionally drawn this wave. So one sec. Yeah, whenever you, let's say over here, one sec. Yeah, let's say it is over here. So you see, one cycle is taking around 4 seconds. Okay, one cycle is taking, let's say, 4 seconds. Now let's say if I decrease the time period of the waveform. Okay, time period of the waveform. Now you see, one cycle is taking roughly around 2 seconds. Okay, it is taking 2 seconds. So when you decrease the time, the frequency increases, right? Because if I just copy paste this particular thing, so I can actually manage one more waveform, 2 more waveform to show over here. Getting the point? Okay, I'll just erase that. That's not required. On contrary, if you increase the time period of the waveform, you are decreasing its frequency. This is what it means, right? This is what this particular formula means. If you increase the frequency, you are decreasing the time, or rather, if you are increasing the time period, you are decreasing the frequency. Once again, I'll show it to you. See, over here, 2 waveforms are taking 8 seconds. That means this one complete waveform, it is taking 4 seconds, right? Let's say if I am decreasing the overall time period of the waveform, that means what? Now in 4 seconds, we are getting 2 such waveforms, right? Okay, so we just decreased the time period. Okay, we just, one second. we just decreased the time period. So what does that mean? That means my frequency got increased, right? You see, a frequency of the signal got increased, right? This entire cycle, it got completed within 2 seconds. Okay. Now let's say if I am, let me move it little above, sorry, let me move it a little above. Okay, so now let's say if I am increasing the time period, okay, if I am increasing the time period, what is happening? If I am increasing the time period, my frequency is decreasing, right? Because now this entire 1 cycle, it is getting completed at around 4 seconds, right? So this is what the entire concept is all it is all about, right? About the about the AC and the DC sources. I really hope that you understood that what exactly is the DC source, like what exactly is the DC voltage, what exactly is the AC voltage. I really hope that you understood the difference between them, and you also understood this thing as well, what is square wave, and yeah, all of the things. And there is one question in my mind, so this will be the last part. Yeah, and the question is, according to you, what are these particular waveforms, whether they are AC sources or AC waveform or DC waveform? According to you, what kind of waveforms are they, AC or DC waveforms? Just pause this video, take your own time, just pause this video and try to think. According to you, are they DC signals or are they AC signals? Alright, I believe that you all guys have tried your best. Now it's my turn to explain it. Well, the signals that you are seeing over here, all of them, they are AC signals. They are AC signals. AC signals. And now I know most of you all guys, you might have doubt, like what exactly is the frequency? Well, the frequency of this signal is, I don't know. It has multiple frequencies. It has multiple frequencies. Okay. You see, because you see at every second the voltage is changing, right? Let's say over here if we have 2 volts, right? At very next second we have, let's say, 1 volt. At very next second we have 5 volts, right? So its frequency is changing. We really don't have any idea about its frequency. So I'll write over here as multiple frequency. It has multiple frequency embedded in it. Multiple frequencies. So it is like my voice signal, right? So whatever voice you are listening to me, you are listening, okay? Whatever the voice you are listening, obviously it will be in this shape only, right? Or maybe this, right? Because let's say I'm saying hello, so it will be something like this. And then I will say hello, so it will be something like this, right? Hello, 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 right? Something like this. So this is a kind of AC signal because it is changing with respect to time. Okay, but it has multiple frequencies, right? If I go over here, so the frequency is quite high. If I go over here at this particular part, the frequency is quite less. Okay, I hope you are able to understand this entire scenario. Okay, and with this we end this particular part, and I really hope that you enjoyed this particular session. Okay, you not only understood that what exactly is the AC and DC source or AC and DC voltage, but you also understood its other parameters based upon that, like frequency. You, like, more than understanding, you felt this particular concept. The feeling is important, right? What exactly is the frequency? Okay, what if I increase or decrease the overall frequency or the overall time period of the signal? What exactly happens, or what generally happens with the entire circuit or with that particular signal? Okay, so with this I will end this particular session. I really hope that you enjoyed this particular session. You understood each and everything that we discussed till now. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I will be happy to help you out there. Thank you for listening patiently. I'm ending this video over here. Thank you.